We're going to be working with rational expressions over the next 2 days. But before we really look into it deeply, I want to go back and remember and refresh ourselves on what domain means. The domain is the set of values, x values, that the function is defined. So what numbers can I plug in for x in my function to get a result? Well, if we have a polynomial, example 1, A, B, and C, these are all polynomials because we have whole number exponents that are positive. The domain for all these polynomials is always going to be negative infinity, comma infinity. Now, the range may be different depending on the type of polynomial, but for any polynomial, you can always plug in any number and get a result. So polynomials, easy. However, we have a rational or a fraction. Remember, we cannot divide by 0. So in our rational functions, we have to focus on the denominator and say what value makes that 0, and that is what we can't have in our domain. The numerator is allowed to equal 0, but the denominator is not. So we say x minus 8 equals 0, x equals 8. So our domain would be x cannot equal 8. Now, letter B, again, that denominator, set that equal to 0. If we want to factor that first, so we get x minus 3 and x minus 2 equals 0. So our two zeros are x equals 3 and x equals 2. So our domain would be x can't equal 3 and x can't equal positive 2. Then letter C, again, factor the denominator, x times x minus 1, and our denominator is x can't equal 0, and x cannot equal positive 1. Okay, that's what makes our denominator 0. So when we have a rational function, we're always looking at the denominator and asking ourselves what would make the denominator 0. Those values cannot be in our domain. Now, with radicals, remember we cannot take the even root of a negative number. At first it was we can't take the square root of a negative number, then we expanded that to any even root, 4th, 6th, 8th root, and so on. Odd root is no problem. So here we have the square root of x minus 8. So we actually need this to be greater than or equal to 0. X minus 8 is greater than or equal to 0. And when we add 8 to both sides, x has to be greater than or equal to 8. So our domain is going to be 8 comma infinity with a bracket around 8 because 8 is included. We can take the square root of 0. That is allowed. So that is why we can have a bracket. For letter B, it's a cube root. So the domain of all cube roots is negative infinity comma infinity. Now, letter C combines a square root and a fraction. So just like in letter A, this can't be a negative number, but it also can't be 0. Because if that square root is equal to 0, then we have a 0 in the denominator. So x minus 1 has to be greater than 0, not like back here where we said greater than or equal to. So we add 1 to both sides. X has to be greater than 1. So then our domain is 1 with a parenthesis, comma, infinity. So any number bigger than 1 would work in our domain. So now let's look at some rational expressions. We're going to reduce these rational expressions by factoring the numerator and denominator if possible, reducing common factors, and then including the domain. When we look for the domain, though, we have to look at the original function, not our simplified one. Because if you look at example 1 here, we can simplify this, divide the top and bottom by 5, and we get 3 over 2, and x squared over x will be x to the first power in the numerator. Now, if we look at our simplified answer, we would think that the domain is all real numbers because there's no x in the denominator. But originally, we had an x in the denominator, so we know that x cannot equal 0. So it might be a good idea to look at the domain first and then simplify if you want to do that. Now, number 2, we see that we have an x in the denominator, so we know that x can't equal 0. But let's simplify this. 18 over 21, divide the top and bottom by 3. We get 6 over 7. And then our x to the third over x to the fourth will give us x to the first in the denominator. We still have x in the denominator, so it's still easy to see that our domain is x cannot equal 0. Number 3, all right, we can factor the numerator and denominator. When we factor the numerator, we get x plus 10 and x minus 2 over x plus 10 times x plus 1. Now we can see that the x plus 10 factors will cancel out. So our simplified version is going to be x minus 2 over x plus 1. But if we look at our original factored form, we know that our domain x cannot equal negative 10 and x cannot equal negative 1. But again, if we look at our simplified answer, we're missing that x equals negative 10 solution to the denominator. So factor, then cancel, and then when you figure out the denominator, always look back at the original. Probably the original factored form would be best. On the next page, if we look at number 4, right now it may seem like with number 4 there's nothing we can do. However, that denominator is the sum of cubes. So let's go ahead and factor that just to see if it will simplify with anything in the numerator. In the numerator, I'm also going to factor out a y to the first power. So I'm going to have y times y squared minus 2y minus 3 over the sum of cubes says this is going to be y plus 1 times y minus y squared minus ab, so 1y, plus b squared, which is going to be 1. Now back to the numerator, that y squared minus 2y minus 3, we can rewrite that, and I'm going to rewrite it down here, we can rewrite that as y plus 1 times y minus 3 over y plus 1 times y squared minus y plus 1. We can then cancel off the y plus 1's, and then we're left with y times y minus 3 over y squared minus y plus 1. Now, we do need to make sure that the denominator here cannot equal 0. If you were to try to factor that, you would not be able to factor that, and the quadratic formula would not give you any solutions. So this would be our factored form. Then we look back and see anything with the domain. In the original function, we have y to the third plus 1. Y to the third plus 1. We cannot have that equal 0. Subtract 1 from both sides. Y to the third equals negative 1. You can take the cube root of a negative number. So cube root of both sides, that is going to give us that y is equal to negative 1. So plugging in negative 1 will give us a 0 in the denominator. So our domain is y cannot equal negative 1. Example number 5 here, we can factor the top to x minus 8 times x plus 8. That's a difference of two squares over, instead of writing that as 8 minus x, I'm going to write that as negative x plus 8. I'm then going to factor out a negative 1 from the denominator. So then x minus 8 times x plus 8 over, when I factor out a negative 1, that becomes positive x minus 8. Well, now the x minus 8s will cancel, and we are left with x plus 8 over negative 1, which can be simplified to negative x plus 8. Now we look again at the original denominator. X cannot equal 8 would be our domain. Right, number 6 here. I'm going to rearrange this to say negative x to the third plus 2x squared minus x plus 2, put it in standard form, over x minus 2. Now I'm going to factor the numerator by grouping. If you look at the numerator, I can factor out a negative x. So I'm going to have negative x squared over x minus 2. And then looking at the second 2, I can factor out a negative 1, and that gives me x minus 2 as well, all over x minus 2. So then that gives us negative x squared minus 1 times x minus 2 over x minus 2. Well, the x minus 2's cancel, and we're left with negative x squared minus 1. Now you may say, well, isn't that a difference of squares? It's not a difference of squares because of that negative in front. So that would be as simplified as we can go. And in the original, our x could not equal positive 2. That is our domain. And then when we look down here with operations, well, we do operations with rational expressions. When we multiply straight across. So first we're going to factor everything. So x squared plus 3x minus 10, that's going to factor to x plus 5 times x minus 2 over x times, and then the second fraction I can factor out an x, and that's going to give me x plus 2. And then the denominator, I can factor that to x plus 5 times x plus 2. And then if I have a factor in the numerator or denominator, I can cancel them out. So I have an x plus 5 in the numerator, x plus 5 in the denominator, x minus 2 in the numerator. There's nothing I can cancel that out with. I have an x in the numerator and denominator, an x plus 2 in the numerator and denominator. So my final answer is just x minus 2. Now the directions here did not say anything about listing the domain, so we are able to just say x minus 2 is our answer. Example number 2. We have a difference of cubes, x to the third minus 1, and we have a difference of squares in the denominator, x squared minus 1. So our difference of two cubes, our a value is x and our b value is 1. So the first fraction is going to be x minus 1 times x squared plus 1 times x, which is x, plus b squared, so plus 1 squared, which is 1, over x plus 2. Our second fraction is just x plus 2 squared, so there's two of them, over x minus 1 times x plus 1. Then we start canceling things out if we see them in the top and bottom. X minus 1, x minus 1. We have an x plus 2 in the denominator and two x plus 2's in the numerator, so we can cancel one of them. So then we are left with the x squared plus x plus 1 times x plus 2 over the only thing in the denominator is x plus 1. And that would be our simplified expression. Number 3 has another difference of cubes, y to the third minus 8. So if we factor that, this time our a value is y and our b value is 2. So that's going to look a little bit different. So y minus 2 times y squared plus 2 times y, so 2y plus b squared, so that's going to be 4 over 2y to the third times 4y over, and we'll factor that, it's going to be y minus 2 times y minus 3. And then we'll go through and cancel any common factors. Y minus 2, y minus 2. 4 and 2 cancel, and I'm left with 2 in the numerator. And then with the y's, I have y to the third in the denominator and a y, so those would cancel, and I'm left with y squared in the denominator. So that leaves us with a final answer of 2 times y squared plus 2y plus 4 over, we have y squared times y minus 3. We can't simplify that any further, so we can just leave it like that. Right, our last two examples have to do with dividing. If you can multiply these, then you're going to be able to divide them with no problem. Because when we divide, all we're going to do is flip the second fraction and change it to multiplication. So then once we do that, we can see that we have 5's in the numerator and denominator, x minus 3 in the numerator and denominator. So our simplified answer is just going to be x plus 2 over x minus 2. So here we have a fraction over a fraction, which again, we can just take this, change it to multiplication, and flip the denominator. So again, this is really equal to x squared minus 1 over x, and we're going to factor it in a minute, times the bottom one flipped, x over x minus 1 quantity squared. So we can factor the numerator to x minus 1 times x plus 1 over x times x over x minus 1 squared. Can cancel out x minus 1 and one of the x minus 1's in the denominator, and then x and x. So now we are left with, in the numerator, just x plus 1, and in the denominator we're left with x minus 1. So again, if you can multiply then division should not be that difficult. Just change it to a multiplication. Just remember to flip the second fraction. If you're struggling with factoring difference in sums of cubes, that's okay. You're going to get better at it. But I want you just to understand the process that you're going to factor and then cancel common factors in the numerator and denominator. So thanks for watching. Make sure to like this video and subscribe.